Question. Look at this diagram. There are two charges minus q each on left and right side, and at the midpoint of the line joining there is a third charge plus q is placed. Now we are asked to move this plus q on either one of these four directions, A1, A2, B1 and B2. We are asked to find in which direction this charge plus q would be in stable equilibrium. Let us read the question now. Two identical point charges of magnitude minus q are fixed as shown in the figure below. A third charge plus q is placed midway between the two charges at the point P. Suppose this charge plus q is displaced a small distance from the point P in the directions indicated by the arrows. In which directions will plus q be stable with respect to the displacement? Option A, A1 and A2. Option B, B1 and B2, option C, both direction, and option D, no stable. Let us look into the answer. So here you have the setup. Now the plus q is moved on my right hand side, that is along A2. I find that the force on this plus q due to right hand side minus q will be greater than the left hand side minus q. So the Fr is greater than Fl. So the plus q will start move towards right and it will not back to the same old point P. So it is in unstable equilibrium. The same thing happens when the plus q is moved towards left, that is along A1 direction. So let us move this plus q along B2 and find what are the forces acting on it. The first force is along right hand side minus q towards minus q on the right hand side. This Fr is resolved into two components, Fr cos theta towards my right and Fr sin theta in just vertically upward direction. Then another force acting on the same plus q towards left hand side minus q, it is Fl. This is resolved into two component, horizontal component Fl cos theta, that is on my left hand side, and again Fl sin theta, that is vertically upward direction. We find that these two forces Fl cos theta, Fr cos theta are equal and opposite in direction. So they cancel each other. Fl sin theta, Fr sin theta are same magnitude, same direction, and takes this plus q charge towards the point P. So if you displace the plus q in the direction of B2, the force acting on this plus q, the resultant force or the restoring force acting on plus q, takes the plus q back to the point P. So the plus q is in stable equilibrium. Similar things happen when the plus q is moved towards B1. So the right answer is option B, B1 and B2.